Hi guys, in this video we're going to discuss about group 16 elements. Under group 16 we will be looking at group trends, hydrides of group 16 elements, oxygen, sulfur, oxygen containing compounds, hydrogen peroxide, sulfur containing compounds, and oxo acids of sulfur. These are the topics we are going to discuss in this video. Please don't forget to revise. I will be including every important points in our syllabus. Please don't forget to take notes. I hope you are ready. Let's hop into the video.
What is group 16 elements?
Elements
With valence shell electron, valence shell electron, Ns2, Np4. Let's look at the group trends now. Downwards the group, metallic character, radius. This metallic character increases, radius increases down the group. Now let's look at the elements of group 16. What are the group 16 elements? First element, oxygen, sulfur, selenium, tellurium, and polonium. Oxygen and sulfur are non-metals. These are non-metals. Selenium, tellurium, polonium are metals. These are not true metals. Not true metals. Because they show metallic property and non-metallic property. Shows both metallic and non-metallic properties. Except hydrogen, all of them are solids. This is a gas and these are solids. Except oxygen, they show +6 to -2 even number oxidation state. Except oxygen, I'll mark it like this. Oxidation state, even number oxidation state from +6 to, they show from +6 to -2, +6, +4, +2, 0 and -2. This is oxidation state of solids, sulfur, selenium, tellurium, and polonium. Solids show even number oxidation state from +6 to -2. +6 and -2 oxidation state. Okay, I'll write it as I guess stability of +6 and -2 oxidation state. Decreases down the group. While stability of +4 increases down the group. I'll write it there. Stability of +4 oxidation state increases down the group. Now let's discuss about group 16 hydrides. Let's discuss about group 16 hydrides. Group 16 hydrides. Here all hydrates are covalent hydrides. All hydrides are covalent hydrides. Let's write the hydrides. H2O, H2S, H2SE, H2TE. H2O is an exception here due to its hydrogen bondings. We compare these bond length of them. Bond length is less than the bond length of H2SE is less than the bond length of H2TE. And the boiling point also increases down the group. Boiling point increases down the group. Boiling point. Boiling point increases down the group. And the H2 exception is exceptional case because due to they have H bonds. Exception due to hydrogen bonds. These hydrogen bonds, due to these hydrogen bonds, they have high melting point and high boiling point. High melting point and high boiling point. These hydrides are poisonous. Except H2O, others are poisonous. And the bond angle decreases down the group. Bond length, boiling point, melting point increases down the group. Bond angle decreases down the group. Angle decreases down the group due to result of electronegativity of the central atom decreases down the group. Electronegativity of the central atom decreases down the group. Therefore, the bond length decreases down the group. And the bond length increases down the group due to the larger, when going down the group, the central atom's radius increases down the group. Our next subtopic is oxygen. Let's discuss about oxygen. Oxygen has two allotropes. Two allotropes. First allotrope is oxygen, O2, and second allotrope is O3. We call this as dioxygen. We call this as ozone or trioxygen. And we know oxygen is a colorless gas. Let's write it down. Oxygen is a colorless gas, and also it is odorless. And oxygen is slightly soluble in water. Oxygen is slightly soluble in water. And the bond length. Let's draw its diagram. This is the structure of oxygen. O2. And let's look at ozone. Ozone is a blue color. Ozone is a blue color gas. Blue color. And it has a smell, pungent smell. It is a powerful oxidizing agent. Therefore, it is used as water disinfectant. Using ozone as a disinfectant is an advantage. Reason, it does not produce any harmful byproducts. But the chlorine, usually we use chlorine. Chlorine produces harmful byproducts. Let's draw ozone's structure. We should balance these. Minus here plus. Catalytic decomposition of potassium chloride and hydrogen peroxide is used to produce oxygen. Catalytic decomposition catalytic decompression. Let's write the reaction. ClO 3 solid is converted to 2Cl solid plus 3O2 gas. Let's balance these. And this reaction occurs in the presence of MnO2OPT. Now next reaction is hydrogen peroxide 2, which is aqueous, and we use MnO2 as a catalyst, and 2H2O liquid as O2 gas. Now let's discuss about sulfur. 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 Sulfur can be classified into two groups. They are crystalline sulfur, amorphous sulfur. We'll divide them. Crystalline, amorphous. Crystalline sulfur and amorphous sulfur. These crystalline sulfurs are S8 sulfurs. Amorphous sulfurs are large thick sulfurs. They are large thick. Crystalline sulfur has two types: rhombic sulfur and monoclinic sulfur. Have two types: rhombic sulfur, alpha sulfur. Rhombic sulfur, alpha sulfur. This is monoclinic sulfur. Monoclinic sulfur. It is beta sulfur. Monoclinic sulfur is beta sulfur. Sulfur loves to form single bond rather than forming double bond. They form single bond. Single bonds with its own atom. When rhombic sulfur, alpha sulfur or rhombic sulfur is heated above 93 degrees Celsius, rhombic converts to monoclinic. Rhombic sulfur is most commonly found sulfur. Rhombic, right here. Commonly found sulfur is rhombic sulfur. And below 95 degrees, rhombic is more stable. Rhombic sulfur is more stable. Rhombic sulfur is more stable. Amorphous form have three types of sulfur. First, three types. First, they form colloidal sulfur. First one, colloidal sulfur. Second, milk of magnesia. So the second one, plastic sulfur. Third, milk of magnesia. Amorphous sulfur. How the amorphous sulfur is obtained? They are obtained by adding melted sulfur into H2O liquid. They are malleable, but unstable. They are malleable but unstable. But they can amorphous form can be converted into amorphous form with time. They convert to crystalline form.
Now let's discuss about oxygen containing compounds. Under group 16 elements, there are two oxygen containing compounds. They are H2O and H2O2. Water and hydrogen peroxide, H2O2. This is water, this is hydrogen peroxide. Let's know the structure of water. O, single bond hydrogen, and a lone pair here, and a lone pair. And now let's do the structure of hydrogen peroxide. O, O, H, lone pair, lone pair. What is the angle between the bonds in the water? What is the angle between the bonds in the water? They are 104.5 degrees. 104.5 degrees. What is the angle between the bonds of hydrogen peroxide? They are 94.5 degrees. Water is widely used as solvent. Widely used as solvent. Water we use as solvent, and we can consider water as a amphoteric molecule because they show acidic and basic properties. That's right. Can act as acid and base. Can act as acid or base. Can act as acid and base. Therefore, we call it as amphoteric molecule. Hydrogen peroxide is a non-planar molecule. Planar molecule. We call it as a laptop model. So this is a laptop. I'll draw laptop. Laptop. Okay. The laptop, and oxygen atom here, and another oxygen atom here. Bonded like that, and the hydrogen is connected here. The other hydrogen is connected like this. These are the lone pairs. We call it as laptop model, non-planar model. Don't write it as laptop model. Just remember this. The angle between them, this angle between two planes are 111.5 degrees. This structure reduces the minimum repulsion between the lone pairs found in the oxygen atom. We'll write it down. This structure reduces the minimum repulsion between lone pairs of oxygen, the O atom. And hydrogen peroxide is a viscous fluid. It's a viscous liquid, or a gas liquid, and it can act as oxidizing agent and also as well as reducing agent. Can act as oxidizing agent as well as a reducing agent. Can act as a oxidizing agent as well as a reducing agent. We write oxygen H2O2 oxidizes O2 gas, and H2O2 reduces H2O liquid. Now let's look at the reactions of water. There are only 3 reactions under the water. Reactions with water.
That's a self-ionization reaction. Let's write it down. H2O liquid. This is a reversible reaction. They self-ionize into H3O plus equals plus OH minus aqueous. We'll balance it to H2O. This is the first reaction. And the second reaction with water reaction is with acid. With acid. We'll write the reaction down. H2O liquid plus HCl aqueous. This forms H3O plus and Cl minus aqueous. And third reaction is with base. H2O reacting with ammonia aqueous, which is this is also a reversible reaction. NH4 plus ammonium ions and hydroxide ions. These are the three reactions for water under this topic. Now let's look at the reactions of hydrogen peroxide. There are about 7 reactions for hydrogen peroxide. Let's write it down. Reactions of hydrogen peroxide. Reaction of hydrogen peroxide. There are about 7 reactions. 7 reactions to memorize. Let's look at them one by one. First, reducing half reaction. Reducing half reaction of hydrogen peroxide. Reducing half reaction of hydrogen peroxide, H2O2 aqueous plus 2H plus aqueous plus 2 electrons, and they form 2 H2O molecules. They form 2 H2O molecules. This is a reducing half reaction of hydrogen peroxide. Now let's look at the oxidizing half reaction. Oxidizing half reaction. Oxidizing half reaction. Okay. H2O2 aqueous forms 2H plus aqueous plus 2O2 gas plus 2 electron. This is the oxidation half reaction of hydrogen peroxide. Now let's look at disproportionation reaction of hydrogen peroxide. Let's write it down. Disproportionation reaction of hydrogen peroxide. Okay. These 2 H2O 2 aqueous, they disproportionate into oxygen gas plus 2 H2O liquid. This is a disproportionation reaction of hydrogen peroxide. Okay, now let's look at the next reaction. Next is with H2O2 as oxidizing agent. Okay, let's write it down. O2 as an oxidizing agent. Hydrogen peroxide as oxidizing agent. Let's write the reactions. Okay, H2O2 aqueous plus 2H plus aqueous plus 2I minus aqueous. They form I2 aqueous plus 2H2O liquid. Here, let's look at this reaction. Here, this I2 have 2 minus, they are converted to 0. This is an oxidizing reaction. There is another reaction for hydrogen peroxide as oxidizing agent. Let's look at it. H2O2 aqueous plus 2H aqueous plus 2Fe2 plus aqueous. They will form 2Fe3 plus aqueous plus 2H2O liquid. Sorry, this is -1. This is -1. Here it is plus 2 plus, and they are converted to 3 plus here. Oxidization. Now let's look at hydrogen peroxide as a reducing agent. As a reducing agent. To show that the hydrogen peroxide acts as a reducing agent, we are using MnO4 minus and Cr2O7 2 minus. Let's write down the reaction. 2 MnO4 minus A aqueous plus 5H2O2 aqueous plus 6H plus aqueous, which forms Mn2 plus aqueous plus 5O2 gas plus 8H2O liquid. Here the reaction MnOE plus 4. They are converted to plus 2. This is a reduction reaction. There is another reaction. Let's look at it. Cr2O7 2 minus is aqueous plus 3H2 3H2O2 aqueous plus 8H plus aqueous. They are converted to 2Cr3 plus aqueous and 7H2O liquid plus 3O2 gas. Here the oxidation state of the chromate in the chromate Cr is plus 6. Here it is converted to plus 3. The reduction reaction. Now let's look at sulfur containing compounds. Let's discuss about sulfur containing compounds. Sulfur containing compounds. Sulfur containing compounds. Under this topic, we will be discussing about H2S, hydrogen sulfide, and hydrogen dioxide. H2S SO2, hydrogen sulfide and sulfur dioxide. Hydrogen sulfide is a colorless gas. Hydrogen sulfide is a colorless gas, and it is a toxic gas. And it is an acidic gas. And it has a smell of rotten egg. Odor of rotten egg. Sulfur dioxide is also a colorless gas. It acts as oxidizing agent as well as reducing agent. Oxidizing agent as well as reducing agent. Act as oxidizing agent and reducing agent. Gas sulfur dioxide is soluble in water. Hydrogen sulfide is also soluble in water. H2S gas dissolved in water and form a weak acidic solution. With H2O forms weak acidic solution. Forms a weak acidic solution. Two, three, four.
And also H2S produces metal sulfides with strong acids. Produces metal sulfides with strong acids. Strong acids. H2S also act as a reducing and oxidizing agent. Act as a reducing as well as oxidizing agent. Write this oxidizing agent as well as reducing agent. Now let's look at the reactions of hydrogen sulfide. Reactions of hydrogen sulfide. Reactions of hydrogen sulfide. There are about 8 reactions in our syllabus for hydrogen sulfide. Let's look at them one by one. First, H2S, hydrogen sulfide as an acid with strong bases. Hydrogen sulfide as acid with strong bases. H2S as acid with strong bases. Okay, strong base, sodium hydroxide aqueous plus H2S gas. They form, this is excess gas, excess H2S, excess H2S, they form NaHS solid plus H2O liquid. And the sodium hydroxide aqueous H2S, same products, but this is limited hydrogen sulfide. They form Na2S solid plus H2O liquid. That will be 2H2O liquid. Let's balance the reaction. 2. Okay. Hydrogen sulfide reacts with metal as an acid and as well as an oxidizing agent. Let's write it down. H2S acts as an acid with metals as well as oxidizing agent. Oxidization agent. When H2S is reacted with the metals, they act as acid and also oxidizing agent. Now let's look at the reactions. There are 3 reactions under this. The first reaction is sodium, metal sodium. Na solid plus H2S gas, excess gas. They form NaHS, which is the same product as above. Solid plus, but the second product is different. It, above product they form H2O. Here they produce H2 gas. This reaction H2S. This is 2. This is also 2. The next one, Na solid plus H2S gas limited Na2S solid plus H2 gas. Mg solid, next reaction is Mg solid plus H2S gas. They form magnesium sulfide and H2 gas. We can see here the metals react with hydrogen sulfide and form metal sulfides and H2 gas. When reacting with base, they act as acid and they form metal sulfide and H2O liquid. Now let's look at H2S, hydrogen sulfide, as reducing agent. H2S as a reducing agent. H2O2, sulfur dioxide, hydrogen sulfide all act reducing agent with
MnO4 2 minus, MnO4 minus, and Cr2O7 2 minus. Let's look at the reaction. MnO4 KMnO4 equals plus 3H2SO4 equals plus H2S gas, 5H2S gas. They form K2SO4 equals plus 5S solid plus 2MnSO4 manganese sulfate equals plus 8H2O liquid. The next reaction is K2 already imbalance. This is 2 K2 Cr2O7 equals plus 4H2SO4 equals plus 3H2S gas. They form K2SO4 equals plus Cr2SO4 chromate sulfate 3 equals plus 3 sulfur solid plus 7H2O liquid. And the next reaction is H2S with sulfur dioxide. H2S plus SO2 is a gas, this is also a gas. They form 3 sulfur solids and 2H2O liquid. They all form as reducing agent. They form solid sulfur, form sulfur solid. Now let's look at the reactions of sulfur dioxide. Let's look at the reaction for sulfur dioxide. Reactions of SO2. Reactions of SO2. First, as oxidizing agent. SO2 as oxidizing agent. As oxidizing agent. Magnesium solid plus SO2 gas, they form MgO solid plus sulfur solid, and magnesium plus SO2 gas, they also form MgO plus MgS. This is also solid. When the magnesium is excess 3. Depends on the situation. These both are solid and we should have 2. Okay. Next reaction, SO2. Let's look at this reaction. SO2 as reducing agent. SO2 as reducing agent. Here the Mg magnesium, this magnesium is 0. Here also magnesium 0. They are converted to, the oxidation state is plus 2 here. Here also plus 2. Here also it's plus 2. Okay, let's look at SO2 as reducing agent. Let's write the reaction first. The same KMnO4 Cr2O7. Okay, KMnO4 equals plus SO2 gas plus 2H2O liquid, and they form K2SO4 equals plus 2MnSO4 equals plus 2H2SO4. And the next we balance this. It should be 2, and the sulfur dioxide is 5. That's it, it's my balance. And the next one is K2Cr2O7 equals plus H2SO4 equals plus 3SO2 gas. They form K2SO4 equals plus Cr2SO4 3 equals plus H2O liquid. And we have another reaction for reduction SO2 as reducing agent. Start the reaction. SO2 gas plus FeCl3 equals plus H2O liquid. They form H2SO4 equals plus FeCl3 plus HCl equals HCl equals. Let's balance this. Fe 2Fe, sorry, this is FeCl2 equals, and the H2S is balanced, and this is 2HCl. These are the reaction for SO2 as a reducing agent. SO2 as reducing agent. These are the reactions for SO2 as oxidizing agent. Reducing agent, oxidizing agent, oxidizing agent. Reactions of SO2. Our next topic is oxo acids of sulfur. Let's write the heading oxo acids of sulfur. Acids of sulfur. There are 3 oxo acids of sulfur. First, sulfuric acid, second, sulfurous acid, third, thiosulfuric acid, Formula of sulfuric acid, we know H2SO4. The sulfurous acid's formula is H2SO3. Thiosulfuric acid's formula is H2S2O3. Sulfuric acid is a diprotic acid. What is diprotic acid? They can release 2 H plus. Write down diprotic acid can release 2 H plus. Diprotic strong acid. Okay. Strong diprotic acid. The H2SO4 act as a dehydrating agent. H2SO4 can act as a dehydrating agent. Can act as dehydrating agent. And the CONH2SO4 is a strong oxidizing agent. CONH2SO4 is a concentrated H2SO4 is a dehydrating agent. This is also concentrated H2SO4. CONH2SO4. The next CONH2SO4 as oxidizing agent. CONH2SO4 is a oxidizing agent. Now let's look at sulfurous acid.
Sulfurous acid is weaker acid than H2SO4. It is weaker than H2SO4. Weaker acid than H2SO4. But this is weak. This is a weak acid. Weak acid. Now let's look at the reactions of H2SO4. How we can produce H2SO3? By reacting SO2 with H2O, they will form H2SO3, and this H2SO3, by reacting with oxygen, they can form H2SO4. They can form H2SO4. What is the oxidation status of these sulfurs? Here I'll mark, I write it here. Okay, wait. This sulfur plus 6 oxidation state. This sulfur plus 4 oxidation state. This sulfur also plus 4 oxidation state. Okay, now let's look at thiosulfuric acid. Only the salts of thiosulfuric acids are stable. Only the salts of H2O3 2 minus are stable. Thiosulfuric ion can oxidize as well as they can reduce. Can oxidize, can reduce. They can act as oxidizing agent as well as a reducing agent. Reduce. In aqueous solution, the thiosulfuric acid decomposes. They form solid sulfur and sulfur dioxide and H2O liquid. Let's write the reaction on the reaction. H2O4, sorry, O3 aqueous, they decompose to solid sulfur plus SO2 plus H2O plus H2O. Reducing the reaction, plus 4, here the oxidation state is plus 4 and is converted to 0 here, and it's plus 4 here. Now let's look at the reaction. Thiosulfuric ion as a reducing agent. As reducing agent. This is the reaction. S2O3 2 minus plus I2 aqueous. They form S4O6 2 minus aqueous plus 2I minus. Here the oxidation state of iodine is 0, and here it is converted to act as a reducing agent. Now let's look at the structures of them. Okay. Lewis structures. This is the structure of H2SO4 sulfuric acid. S double bond oxygen, here one OH and another OH, the OH. This is the structure. Let's draw the structure of sulfurous acid. S double bond oxygen, OH and OH. I'll draw the thiosulfide structure, thiosulfuric acid structure. S double bond S, OH double bond O and another OH. This is the structure of thiosulfuric acid. Now we should look at the reactions of sulfuric acid. How can we produce sulfuric acid? We can produce sulfuric acid by reacting sulfur trioxide with H2O. Let's look at the reaction. I forgot to mention that. SO3 plus H2O will form H2SO4. Here it forms sulfur dioxide plus H2O forms sulfurous acid. But here it sulfur trioxide plus H2O form H2SO4 sulfuric acid. These are the two reactions. Now let's look at the reactions of sulfuric acid. Reactions of sulfuric acid. No, sulfur dioxide is a diprotic acid. What is diprotic acid? They can release two protons, 2H plus O H3O plus. Let's look at the reaction when we add sulfuric acid equals to water. They dissociate. HSO4 minus equals, and they release the proton. And this HSO4 minus equals plus another molecule of water. They will form sulfate ion plus H3O plus aqueous. This is the reaction. The overall reaction, you can write the overall reaction here. H2SO4 equals plus 2H2O liquid form sulfate ion equals plus 2 form 2H3O plus equals. We learned that the sulfuric acid is concentrated sulfuric acid is a dehydrating agent. Let's look at that reaction. As H2SO4 as dehydrating agent. Now suppose we have two dehydrating reactions under sulfur H2SO4. Let's look at those reactions. C6H12O6. What is this? What is this C6H12O6? It is glucose. Six carbon solid plus 6H2O gas. We should add, to this reaction to occur, we should add CONH2SO4. We should add CONH2SO4. The next reaction is, let's look at the next reaction. C2H5OH, which is a liquid. They form C2H6 gas plus H2O liquid. For this reaction, we should add CONH2SO4. If we add CONH2SO4 for glucose, they will act as a dehydrating agent. They will remove water from the glucose. And our next subtopic under sulfuric acid reaction is CONH2, hot concentrated H2SO4. Okay, concentrated hot H2SO4 can act as oxidizing agent. As an oxidizing agent. Let's look at the reaction. H2SO4 reacts with metals and non-metals. They form sulfur dioxide and H2O liquid. Let's look at the reactions. First, let's look at how they react with metals. With metals, H2SO4 liquid plus magnesium solid. They form sulfur dioxide gas
plus magnesium sulfate is aqueous plus water. Let's balance this too. And the next reaction is H2SO4 with copper. They form sulfur dioxide and the relevant sulfate, metal sulfate plus H2O liquid. This is the reaction with metals. They form sulfur dioxide, water, and the metals. I'll write a common reaction for this. H2SO4 plus metal forms SO2 gas plus metal sulfate plus H2O. This is the common reaction. Now let's look at the reaction with non-metals. Non-metals. Let's look at that reaction. H2SO4 plus sulfur solid. This liquid 2. They form SO2 gas plus 2H2O liquid. The next reaction is with carbon. 4 plus carbon solid. They form carbon dioxide, sulfur dioxide plus 2H2O liquid. Next reaction, next topic under sulfuric acid is diluted H2SO4 reacting with base. Diluted H2SO4 as acid. This is our next subtopic. Let's look at the reactions. There are only two reactions with the base. H2SO4 equals plus NaOH equals acid plus base, they form salt, NO2SO4 and water, liquid. The next one, diluted H2SO4 equals plus metal magnesium, they form their sulfate, so 4 is equals plus H2 gas. We already learned that a reaction with concentrated H2SO4 and magnesium, they formed sulfur dioxide, magnesium sulfide and H2 liquid. Here it's diluted H2SO4, they react with H2, diluted H2SO4 reacts with magnesium and form magnesium sulfide and H2 gas. That's all for group 16 elements. Please do periodic revisions. Thanks for watching. Don't forget to subscribe, like and share.